right? And let's say we have a data set. Sorry, please. I'm trying to accept people that are coming in and try to allow the mic. Okay. Mr. Justice, good morning. Jennifer, good morning. How are you guys?
Good morning, sir.
How are you?
Good morning, sir.
What's happening? How are you guys? What's happening? Is it me or there's network issues?
I'm fine, sir. Good morning, sir. I'm fine.
Mr. Justice, let me tell you how you sound. You always sound like as if you are fighting with somebody.
Okay, maybe I will change, sir.
Anyways, we might not do predictive analysis, but I want to show you guys some other data manipulation technique. Okay, so let me see this data set. Where do I pick this data from? Oh, okay, so let me get a particular data set to use.
Open your distance.
Sorry, are you talking to me?
To see if your pipe or gate related.
Mr. Justice, mute your mic. Okay, so I'm trying to look for a data set to use. Okay, so let me get one particular data set. Please mute your mic. So I'm actually going to use this. Again, the first thing you're supposed to do every time is to import your library. I have requests because I want to use it. I'm going to post these. Copy these.
Are you sharing your screen? You can't
yes,
see
I am. Can anybody see my screen?
I can't see your screen.
I can see it from here. I can see it.
It's visible too. I can see it from here.
Go off and come back.
All right, let me off and back.
What did you do to network today, Mr. Joshua? So, mind you, in you see this response here that you see 200. Although you might not be a web developer, but anytime you see 200, response 200, it means that that request you actually make was successful. So if you see something like 404 bad requests, 400 bad requests anytime you visit a website. What that means is that your request was not processed at that particular point in time. So anytime you see response to it means that there's success, you have some level of success in the request that you actually made. So I can just say data is equal to response, then .json. Then I will then say df You can put any variable equal to pv dot read read JSON, I think. Oh, pf dot read underscore JSON. And I put my data there. And hopefully it doesn't give me an error. Oh, it is giving me an error. Why? So it's saying that invalid file path. Oh, sorry. It's not pd dot. So it's a pd dot data frame. Apologies. Data frame. Yeah. And if I do df dot head, I'm going to get some error, and that's because I am supposed to if I call this my data, you can see it has something like confirmed and things like that. Or if I do print data, I have confirmed. And so JSON is basically like a dictionary where you have key object, key value pair. So the confirmed is a key and the rest of what you have here are values. So I'm supposed to say print and I'll say confirmed inside as the key of this particular dictionary. And I'm going to get the value. So basically that's what I'm actually going to do here. I've done this before, just a refresher. Confirmed, and this and this. Now, this is my data. Say for instance, I don't like that this location. Let's say for instance, I don't like that location is what I'm having here. For instance, I want location to be, since I have Nigeria and so on, but let's see the whole of the data set. I have Nigeria, I have Kenya. So basically what it means is that you are talking about country. And so I actually want to change this location to country and yeah. So basically I want to change my location to country, right? So in order for me to have access to the column names, for instance, I can say df dot columns. And I'm going to get my columns, basically, the name of my columns. So the one thing I can do is to say, if I'm correct, I want to change this my location to country instead. I can make a dictionary. I can see column names. So for instance, I'll just say column is equal to, I'll create a dictionary for a key value pair. I would say location, I want it to be country. Country maybe with a small letter, for instance. I can then see, I think if I remember correctly, I can see my data frame dot, there's a function called rename, and it will take my columns and I can then say equal to column. So you can see how now the column that was location has now changed to what? Country. So you can actually do, let's say I want additional information, for instance, additional underscore information. I just want it to be more info, for instance. I can run it and I'll run I'm going to run the next code, and you can see that what was additional information before is now what? More info. So that is one way to actually to do some data manipulation. Any questions? Questions before we continue?
I think we are good to go.
So you understand that part. So there is also a lot of times, right? We usually used to check for null values. Now, if you are trying to do some form of analysis, predictive analysis specifically, you usually check for null values. If values are null, you would say, okay, let me remove null values depending on what exactly are the null values. Sometimes, maybe if you have so many null values in a particular, null values basically are empty. So you have a cell, or you have a particular cell in a particular rule or in a particular column that is empty. So a lot of times, if you are trying to do some kind of analysis, we are actually concerned about null values and how to go about null values. So I think I did this before. So if you want to check if your data has null values, you just call the name of the variable that is holding the data set itself. You now say dot. There's a function called is null. And I think you can either use is NA. And basically, it's going to show you whether or not this data. So it's going to test each and every cell. Is there any null value here? No, it will tell you no. So you can either say is NA or is null. Anyone is NA means not something that is not available. Null is literally null. So is NA or is null? It's going to test each and every cell in that particular data frame. Do I have null value to say no? Do I have null value to say no? So basically, no means false here. Now you can then do a sum of it. If there is any null value, what are the sum? What it's going to do now is going to do, if there are null values, it will count how many are false, how many are true, basically. So you are going to do dot sum, and it's going to give you for every column how many null values are there. So you can see, basically it's telling us that there are no null values. There's another way we can actually look at each and every column if there are null values, which is df.info. Now, info is going to give you like a comprehensive summary of our data frame. So it will tell you the column. What this non-null count means is that non-null, anything that is not empty. So it is doing a count of it. So it means that if this is 8, this is 8, this is 8, and let's say gender here is 7, for instance, it's telling you that there is one null value. Basically, that's what it's telling you. Does that make sense? Hello?
Yes, it makes sense.
So it's telling you, so if you are seeing like all the numbers are the same thing here, and you are just seeing that there is one number that is different, it means that there's one null value. But for sure, if you want to do a count of the null value, this is the formula to actually use, or this is the code to actually use. I'm trying to see some of my data sets if there is okay, I have this data set here. Let me import this data set here. So let's see. new data is equal to pd dot, I think it's a CSV file, right? Dot CSV, and I'm going to import my data. Yeah, I have this data set here. And let me say new dot head. And okay, so now, first of all, this particular data has a name. And let me get the name of each of these data, this column. I'm going to copy it because I don't want to type. I'm too lazy. These are the columns. Now, X1 is relative compactness, X2 is surface area, like that. Now, I want to change these columns. Now, you see this unnamed 10, unnamed 11, you are seeing NA. First of all, it looks like this is an additional column that we didn't put there intentionally. So let's say if we want to actually view this particular the data frame, I can click here, double click on it, and it's going to show me that particular data frame. Sorry, hold on. So you can see what the issue is here, right? It means that there are additional columns, although it is empty. Does that make sense? And if we go to the CSV file and we'll go and open it, let me see. Hold on. Where is this local? Okay, good. So if we go and open it using a note editor, let me see. So if we try to access it using a note editor, you can see this comma. What that means is that there's supposed to be a value here, and there's supposed to be a value that ends it, but there's nothing there for the column. And there's also supposed to be something there. So what we can do is to remove this double comma if we wanted to, but let's say that is a mistake and we want to actually correct it using data manipulation, or what they call in data science, they try to say it is data cleaning and stuff. I really don't like using those terminologies anyways. But let's just say we actually want to do it not from the source data. We actually do want to do it inside our Python. So first of all, like I said, this X1 like that, they have a name called, these are the names. So X1 is relative compactness, Y2 is cooling load. So then what we can then do is to say new equal new dot rename, and we'll now say column names. Yeah, column names is equal to column names. Or let's just say column. Or let's just say this is columns, for instance. We'll just say columns. And what is it? It say that got an expected column names. Is it column names or column name? Oh, columns, sorry. Apologies. So columns is equal to column. So it's supposed to be columns is equal to, well, then I can then say this is column names. So columns is equal to column names. And when I run it, I now do my new dot head, which will give me the first 5 rows. I can then see that I've changed my data now, but I'm having problem with this guy. I want to remove this guy, this person here. So one of the things I can then do is to call out these column names, all of it. So I can, let me copy to this place. That's one way to go about it. I can say my new, then I'll now put the name of the the columns I want to get. For all intended purpose, I choose to copy because, like I said, I'm very lazy. I don't like to, I'm extremely lazy, frankly. I don't like typing. Apologies for that. I don't want you to get confused anyways. So let me see. I actually don't want this plenty space that are here. I can just do a comma here and do a comma here. So I can decide to do this, right? I'll just call the name of the columns. And you can see that it will only give me the name of the columns I actually called and abandon the one I did not call. I can then set it to be my new data. So it's not going to show me anything. Now, when I say new dot head, it's now going to show me my new data set with the names I want, and I abandon the names I don't want, which is this unnamed. That's one way to go about it. The other way to go about it is, so let me just say this is new df. Oh, sorry, minus. This is not a proper reference of. So let's say new df. Now, let me go back to my new. I still have that problem. Oh, no. It's not supposed to show me this. Let me restart my kernel and run all cells. So just give it some time, it will restart. You can see that it's showing something like booting. What's the name of this? This is the, forgotten the name of this stuff. Forgotten. So when I call my new, you can see that I have the on name 10, on name 11. The other way I can go about it is to say new.i location. Now, remember that if you say .i location, you put your square bracket. The first thing you're actually going to refer to here is your role. Then the second thing you are referring to here is your column after the comma. So I can say, give me all the rows, which is what's the name of this? iPhone, right? Then all the columns. And it's still going to give me the same thing. But I don't want the last two. What I can then so is to say, give me from all the rows, but from, I think this is 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9. Heating is 9. Cooling is 10. So I can say, give me everything up to, I think it's from 0 to 11. So the first column is considered 0. And, oh, I don't want 11. It's actually 10. That's one way to go about it. I can decide to say, give me everything before 10. That basically everything that comes before 10. And it's still going to give me that, except, yeah, so it's going to give me that up to the cooling load, which is what I actually want in the first place, right? Or I can then say, another method I can then use, I'll say, so look at what happened if I say -1. Oh, God. No, oh, sorry. Give me everything up to -1. Yeah. So look at what happens. If I say -1, it's going to remove the unnamed 11. Now, if you want to call positive value in Python Pandas. So anything positive value will start from the left to the right. Now, negative values start from the right to left. So if I say -1, look at what happens if I say +0. Let's just say, let me call +0 to 1 to 2, for instance. So give me 0 to 2, index 0 to 2. It will give me relative compactness and surface area, which is 0, 1, minusing the 2. Now, if I say give me everything before 2, it will still give me the same thing. So if I say give me everything before 10, it will give me till cooling. And if I say give me everything to before -1, it's just going to start from, it will start from here, and it will just minus this part here, that is the unnamed one. So if I say -2, so this is basically -1, -2, -3, 4, 5. It's not going to start from 0 because 0 doesn't have negative. So it will be -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So it's more or less, I can then say, give me, so if I just want relative compactness to surface area, I can say, give me negative, I think 11. Oh, so it's -10. And you can see, so you can also use the negative number, but negative number will start from the right to the left. Positive is from left to right. So now if I don't want the unnamed 1 and 2, I'll just say give me -2, and it's going to give me everything except the last 2, which is this unnamed 10 and unnamed 11. Any questions? Any questions? Can I continue?
You can proceed, sir. I'm following.
Is this understandable? Is it understandable?
Yes, it is.
So the same thing with so if I want to use the loc without the index location, I'll have to call the name of this this column, which is actually very, very stressful for me. You understand? I can say new dot loc. Sorry, please just hold on, you guys. Just give me a moment, please. I'm coming. Give me a minute or two.
Hello? Hello, sir. We cannot hear you.
He said we should give him 2 minutes. He will be back. He said we should give him 2 minutes.
Okay, okay.
Sorry, I apologize for that. I had a visitor. So if we want to use the dot, that's the location, which is the location, we have to call the name of the columns. And oh, so this is supposed to be not dot, it's supposed to be comma. And I think I'm going to get some error. I don't know what error it will be, but okay. So because I think I will need to reduce the number of square brackets. Yeah. So I'm basically going to get the same thing, but you can see how stressful it is to use the location function over the index location. Any questions? Any questions? Yes, no. Do you understand? Yes, no. Somebody should respond to that.
We understand. But
Okay,
I
so
want to understand, when is it
yeah.
preferred to use the location function?
No,
over the index?
I'm showing you the disadvantage and the advantages of it. So like now you want to call all the columns you need. You understand?
Yeah,
You have to start calling them. You can see the index location. I just needed to put a number.
Yeah, exactly. The location, the 0, 1, 2. The location.
Okay. So you understand the advantages and disadvantages of it, of using the loc and the iloc, or index location and the location method here. Mr. Mutala?
Yes, sir. Yes, sir. I get it.
Okay, good.
No.
Okay, now this is our data set, right? So if we say data, this is our new data.info. You can then see that our data has 768 non-null counts. But in the reality, look at, I'm seeing NaN here. Can you see this NaN? I'm actually seeing it here. So, and this NaN means, I forgot, is it not available? Not available or something. I've forgotten what none means. But basically, it means that there's nothing here. There's no value here. But it's still telling me that this thing is what? Is a float, but it's showing me 700 and, oh, apologies. It's actually about 1,296 rows, but it's showing me 768. So what it's trying to tell me that is that from the 769th row, there's nothing there. Does that make sense? So what I can then do to confirm this is to say, from our new df, I can use the index location method, and I'll just say, give me everything from 769, then all the columns. Can you see? From the 769th row and all the columns is what you can see is empty. And if I say dot is NA or is null, and I say dot sum, you can see that it's telling me that it has about 527 null values, basically. Please give me a minute, please. Just give me a minute. I'm back. Many apologies, it's my son. So if I say from the 769th row to the last row, do a count of the null values. Yes, you can see it's telling me what? It's telling me that you have about 527 null values. In order to confirm that, again, just to confirm that, I'll say new df without having to put the index location. And I'll now say dot is null or is NA. Then I'll now say dot sum. Oh, so it means that I indexed the wrong location. I think I'm supposed to say 768. Yeah. So if I say the df dot is n is null, then I now say dot sum. You can see it's giving me the same amount of null values it has here when I did the indexing of it. So you can see, despite the fact that we have about 1,296 rows, only 768 rows are what are actual values. The remaining one are null values. Now, if I want to remove null values, being that I know that all the rows after 768 is null values, if I want to remove null values, I can then say new df dot drop NA. If I do drop NA is a method that you use to drop null values. So you can see now my new role is what? 768 rows. That's what my new role is. Does that make sense? It has, so from 1,296, I now have 700 and what? 68 rows of data because I've dropped my null. But if I now say new df, right? It's still going to show me 1,296. So in order for me to make this a permanent data frame, or in our current data frame, after we have removed the null values, we can then put an argument inside here and say in place equal true. So it's telling me that I don't know why this is showing me a warning. And now if I say my new df, you can see I have 768 row. You can either do this, or you can say the other way to go about it is you say, I don't need to put this in place. I'll just say new df equal this, and I'm good. You can either use this one or you can use this. Basically, I'm saying my new df is, this is more or less like any data frame. It can be any variable. The reason why I'm using new df is because this new df is actually what I want my current data frame to look like. So I'm just replacing whatever I initialize my new df to be. I'm replacing it with something new. So I can decide to say df if I want, if I can decide to use anything. You understand? But because I'm going to be using the new df is the reason why I'm doing that. Anytime you are seeing warning like this, there's something you can do to remove it. You would import warnings, I think. Then you now see, I think it's filter warnings. Then you now see ignore. Again, you don't need to memorize this. This is just something I learned over time. There are some other things I learned over time. So if I run this again, I'm not going to get that error. So you can either say drop any, or you now enter an argument in place equal to true. The same thing if I do this. The same thing if I do this. You see this that I did. I can decide to say, watch what happens. Sorry. Hold on. Aha. So you can see if I say, if I just do this new dot rename, and I enter my columns equal to the new column name, it's going to give me what I want. But if I say new dot head, it's still going to go back to the okay, sorry. Okay, let me just restart and run my cells again. It's supposed to give me the x1, x2 like that. I think this is where I am. Yeah, this is where I am. So it's supposed to give me so it's also good, you know, the kind of you should be wary of the kind of data you're actually expecting. Be very, very so it means that you really need to know what you are doing. So because I know I'm expecting something and I'm not getting what I'm expecting. So look, when I say new dot rename and I now say column is equal to this column name, if I say new, you can see it's showing me that what new dot head is still the same data. It didn't do any replacement. It just did a pseudo replacement. So what I can then do is to enter the argument to call in place, and I'll now say equal to true, and I'm going to run all the cell from this current cell to below. And you can see that it is going to give me, so you can see that when I say new dot head, it has given me what I replaced it with. Does that make sense? Any questions? Any questions? Is it understandable? No questions?
Yeah, no question.
Okay, good. So I've removed NA, null values. There's also something I actually wanted to mention. Let me see, what do I want to mention? I want to mention something, but I cannot remember. Okay, so in predictive analysis, basically predictive analysis is trying to do like prediction, what would happen based on what you already know. Now, there's what they call correlation or linear regression. Does anybody remember equation of a straight line? Who remembers equation of a straight line in math? What is the equation of a straight line?
Like y equals to a plus bx, right?
Yes,
a plus bx.
a plus bx or mx plus b.
Yeah,
No,
anyone.
AS plus C.
AX
AS
plus
plus
B.
C.
You can say
Plus
mx
C. C
plus
is the
c.
constant.
Yeah, so it doesn't really have any distance. So you can say y is equal to ax plus b. You can say y is equal to mx plus c.
A plus bx.
You understand? You can say mx plus c, c meaning intercept, or you can say y. You can say y is equal to ax plus c. All is fine as long as you know what it is. So basically, the correlation that you see is or linear regression is basically the equation of a straight line. If you guys remember what our equation of straight line is, let me try and see if I can draw it out. Let me see. I think I have paint. So yep, I have paint. I have a son who is he's the architect of his own cry. He enjoys crying, and I don't know if he enjoys it near or he will do things that will make him cry. He's one I have to excuse myself every time to go and. So basically, if you are talking about predictive analysis, you are just why is this thing not going straight? Apologies. This thing is supposed to go straight. Why is it not going straight? Yeah, so this is eraser too. Oh, this I have to do. This is interesting. Sorry, please. Let me get a different note. I think one note will do the same thing for me. I'm actually trying to use a pad to write. So apologies for that. Let me add a page here. Oh, that's interesting. So basically, if you are trying to do predictive analysis, you have something like this. You have your y-axis, you have your x-axis, which is also known as what? Horizontal axis, and this is vertical, right? Please, you people should not tell me that you have forgotten these mathematics. Then you now have you will now be drawing y against x. If you remember in your math or physics, who remembers?
Yes, sir, we remember.
Who remembers y against x? Then you have another this thing here, you have another one here, you have
Yeah, I
another
can
one here.
remember this.
You have your calibration, your 1, 2, either 3 or so. Your 4 against maybe this is 0.5, 1, 2, 3, like that. Then they will now say you should draw your what? Your line of best fit. Who remembers that?
Yeah,
Yes,
line
sir.
of best fit.
Where it can take as much
Of the points as possible.
of the point as possible. Does that make sense? So basically, if you are doing predictive analysis, your predictive analysis depends on this equation of a straight line. And statistics guys have taken it to a whole new different level, which is a little bit interesting, and part of the reason why I don't like I think it's part of the reason why I don't like data science again. Sorry, Bashman. Bashman, are you there?
No, but sir, it's really interesting.
Okay.
It's really interesting. It's a good one.
No, it is interesting. It is interesting.
The way you
Yeah,
are
because
presenting.
during my undergraduate, I did predicting students' performance using machine learning, and it was very, very interesting.
It is interesting.
Yeah.
I think one of the Bashman, don't take it the wrong way. One of the reasons why I don't actually I don't involve myself in data science a lot these days is because people who have the wrong idea of what machine learning and AI actually is, and it drives me really crazy. I think it's one of the reasons why I don't involve myself in predictions and machine learning and stuff, because people have the wrong idea of it. And I don't think a lot of people understand the basics of AI. And actually, what I usually would tell people is machine learning or predictive analysis or trying to do something AI. Statistics is actually the father of all of this stuff. And if you don't know your statistics very well, yeah, it's going to be really bad for you. And anyways,
So when you say people have the wrong idea, can you expatiate a little on that?
People have the wrong idea. Some people think if you
predict it perfectly.
Yeah, people are now over dependent on that, predicting something perfectly and making business decisions using your predictions. The purpose behind prediction is to give you an idea of what the future looks like.
A guide.
Yeah, exactly.
to give you a guide of what the future looks like. It's not to tell you that something is going to happen in the future.
Yeah, in fact, I bet up what the future might look like.
Yeah, so it's just to give you an idea. And the reason why, so it's just like me telling you that every Friday, who stays in Abuja? Who is in Abuja? Or Lagos? Who is in Lagos?
I'm in Lagos.
Good, good, good. See Oshodi in Lagos. Imagine going to Oshodi around 9 o'clock in the morning. What is it going to look like?
Shit show, traffic.
Exactly. So now you are in Lagos. You are telling me that, see, if you want to come to maybe via flight, if you want to come to Lagos, of course, I will drop in Ikeja, right?
Yes.
Please make sure you come maybe around 12 or 1 o'clock. That time people are at work. There's less traffic. You understand? You are giving me an idea of what my future would look like based on what you think you know. Do you understand what I'm saying?
Yes.
And the reason why you are telling me that, for you, you know. For me, you have given me a prediction. It's not like you know what traffic is going to look like tomorrow, but you already have an idea of what traffic usually used to look like. You understand? You now say, see, around that time, oh, this is it. Then you are now telling me so that I can make better decisions when I'm trying to come to Lagos. Yes. I don't know if you understand that. And
perfectly.
Why artificial intelligence is a very amazing thing. It is not the way people think it is. I don't know if you understand. Machine learning, artificial intelligence is still depend on the people that built it. Some people are thinking that one of these days you create a robot that can think on its own. It's a lie. That is something that can never happen. Do you understand? It is based on logic,
informations,
and access to information. So I keep asking people, what is machine learning or artificial intelligence without internet? It is nothing. What is artificial intelligence or machine learning without having capacity to store
historical data?
Yeah, no, not even historical data now. Capacity to store things.
Okay.
Your hard drive is nothing. Do you understand? So I think it's one of the reasons why I left that field. It's not like I don't find, because I was doing what people call computer vision, that is image recognition, and basically convolutional neural network, what you use for image recognition, object detection. And because I was very, very much interested in those AI facilitated image recognition, that you can give it pictures and you can train it. If you give it enough picture, it will be able to identify what certain object. I was very, very much interested in that, and I went up to that, and actually had I was also interested in Forex, time series analysis, and I did a lot on that. But at a point in time, I just said, let me just stay in my space. Because almost everybody is, and people have the wrong idea of it. Like it drives me crazy. Anyways, that is just a little bit about it. So basically, if you are trying to do predictive analysis, right? Like I said, basically the equation of a straight line, which is our quadratic equation, or what they call this is a linear equation, right? Which is algebra.
Yes, linear equation.
Algebra is like the father of predictive analysis. So it is that is saying that is the assumption is that a factor is dependent on another. Basically, it is saying that the factor y is dependent on what x looks like. So you have what they call a dependent variable and what they call or target. Variable. You call this a target. No, sorry, please, apologies. A dependent variable, which is y, is called a target variable.
Response variable.
Sorry?
Response variable.
Yeah, they have different names for it. Then it's dependent on x, which is an independent variable, or what they call a predictor. So this this x is the one that predicts y. So which is basically the equation of a straight line. Y is dependent on the value of x and some other factors, but basically dependent on x and some other factors. These factors include to get this is slope, right? Which one is slope? Which one is what is this again? I've forgotten this stuff. It's been a while.
What you draw now is that the slope?
Yeah. So this is the slope, and I think this is what? Oh, yeah. So this is the intercept. So this is the slope. Yeah, thanks. This is the slope, and this is what they call the intercept. And they usually used to do the intercept by, I think they would do something like this line here or something. I've forgotten. Or is it this line?
Can statisticians, those guys that study statistics, can they help us understand this in better? When we say slope, we are still repeating the same thing those mathematics teachers did to us in secondary school and university. They confused us.
Yes.
And the reason many of us were unable, what I'm seeing here, that M is the amount of change to Y as a result of X.
Yeah, so which is what they call the...
And then Y relates with X. As a result of the relationship, some things happen. The rate of that change, whether higher or lower, is what M represents, and that's the slope. But they would not be telling us slope, confusing us. This thing suffered me in the university until I met people like you. Help me understand. This is very terrible, and I pray that our children will not suffer this nonsense. Okay. Somebody will just go and climb something that will be telling you X, Y, M is slope, and that is it. They almost made me hate mathematics in secondary school because of this thing. Okay? God bless you, sir.
It's so I studied mechanical engineering. I did mathematics till 500 level. 500 level math, if you are doing math at 500 level and statistics at 500 level, is a very terrible thing to do. I don't pray my head. Sorry, for those people in mathematics department, you guys are really trying. I don't pray. There was a time I entered while I was in 500 level. I entered the class. I think at a point in time we stopped using calculator to do anything because we are dealing with things like Fourier series. There's this math they call what's the name of this math? Abstract math. I don't know if anybody did master's level mathematics or statistics.
Abstract algebra, right?
Yeah, or abstract algebra where you beat. Oh God, that thing. Anyways, good times. So basically, what the slope is you do the calculation based on the change in y, which is the vertical, over the change in x, and you see that in predictive analysis it is it is very important. Now, so if you are doing a prediction, right, you are doing a prediction that based on what has happened, this event that has happened here, you can predict what is going to happen in the future, which is somewhere around this side. And in order to do that, this future here that you don't have like a X and Y value for, in order to do that, right, you are going to train this data that you have here, this already data that you have here. And by the time you train this data, you are able to predict what has happened in the past in such a way that is close to the actual value, which is this guy here. You understand? Okay, I think I should just delete this. Sorry. Apologies for that. Oh, my hands are on this stuff. I think I'll delete this. I don't know why. I don't know how to use this drawing tablet. It's very, very difficult for me. So in such a way that if you want to predict the future, you have to be able to predict the past in such a way that whatever you are predicting is close to the actual reality. Then, if it is very close and the error, the margin of error there is so minimal, you understand? You are saying that, oh, okay, it's close to the truth. It's just like football, for instance, that somebody will say, I bet you that based on Ronaldo. Now, Cristiano Ronaldo has a world record of number of goals and the number of assists and stuff like that. And you know, anytime you see Cristiano Ronaldo or Messi in a football field, you know that most likely that team is going to win. Is that not?
Yes,
and which is
based on their history,
based on what has happened
data
in the past. So basically, if you are doing predictive analysis, is that this is actual data. You want to predict the future, but in order for you to predict the future, you have to make certain assumptions in such a way that by the time you make certain assumptions of the past and you now predict the past, you now compare it with what you already have of past data. And of course, you are going to have error, but the margin of error should be somewhere closer. It is close to zero as much as possible. Do you understand? So the error should be very, very close to zero as much as possible. Once you are able to do your prediction and your margin of error is close to zero as much as possible, then you can then say, I can predict the future, because you almost got it right while you are trying to predict the past. So you'll be dealing with things like the R-square score, the mean square error, the mean what's it again? I think it's MAA, mean. What's the name of this? Oh, who can remind me? Bashman.
Is it mean square deviation?
No. I think it's mean. Sorry, mean absolute error. Yeah. So mean absolute error and things like that. And for anything that has to do with error, your error should be as close to zero as possible. It should be as closer to zero as possible, because anything that is error is that it is error from what it's actually supposed to be. Let's say if this is what it's supposed to be, let me draw a line. If this is what it's supposed to be, your error should be something like this. So it can either be like this or a little bit down. So you're either predicting it correctly or you are predicting it wrongly. But if you are predicting it correctly, it should be close to the truth as much as possible. So your error is this prediction that you are predicting based on what has happened in the past. Then you now say, okay, if my error is close to zero, which is close to the truth, zero meaning this is zero. This is basically this line that you have drawn your equation of straight line. This is your YMC is got to this. This is the truth. Now you are doing a prediction based on certain assumptions. Will be somewhere around here, or you either get it positively or negatively. Now, if you are getting it positive or negative, how close is it to the truth? Which is this guy is zero. So anything you are getting error, where you are getting your error, it should be as close to zero as much as possible. Now, but the less your error is, the more good your prediction model is, basically. So less error, meaning better prediction, basically. And less error means the better your model. So it is when you are now done with this, your model, you will now say, okay, I can predict the future, and you now predict the future based on what has happened in the past. Again, I wanted to, why did I even mention that, Seth? I was trying to get to somewhere. So, but before you get to this particular place, you'd have to do a lot of activities. For instance, you have to check, let's say, if you notice, the main data we had was what? X and Y before. We have a lot of X and we have like 2 Ys. So they usually will call it. So if you have multiple dependent variable, a lot of X's, they call it, if you want to do a prediction based on linear regression, they call it a multivariate linear regression or correlation, basically. And so I think the reason why I mentioned correlation or linear regression is we can then do a test to see among our data, which of them is dependent on the other. And anyone that has a very high number shows that it is very dependent on the other. So there is a particular method or function you use. You call it correlation, which is the short form of it is a CORR, is a function in its own. So I'll say new df dot, I think is, if I remember correctly. Well, it's been a while I did this stuff.
Okay, no.
Please mute your mic. Mute your mic. So we then did a correlation, and we can then see. So the closer it is to 1 or -1, the more correlated it is. So we will say positive correlation, negative correlation. So you can see that between heat loading and relative compactness, we have 0.2, 0.62. Cooling load, we have 0.63. Look at this. This is negatively correlated, and it is highly correlated. Look at this one. It is negatively correlated, but highly correlated between heating load and roof area. They are highly correlated, but negatively. So it means that if one is going one is going positive, the other one is going negative. And so of course, anytime you see 1.0, it means that it is that particular attribute against itself. A lot of the times, if you see 1, and so you are not supposed to get a correlation equal to 1, but if you get a correlation equal to 1, it means that most likely you are matching something against itself. So which is why you see 1. I think there's a way you can visually see this. Let me import another library called, Seaborn. Seaborn is a visualization library, and Seaborn has a method in it called, I think, sns.heatmap. Yeah, heatmap, and I'm going to enter my data. This particular, and it's going to give me some correlation. I think I need to enter some argument. Yeah, so this is basically my heat map. So what this map is showing you is, I think I can also I can add colors to it. Let me see if I remember correctly. So what this is, what you are seeing here, this particular place, 1 to this is negative, right? This is 1 to negative. Basically, this is -1. The darker it is, the more it is to -1. The lighter it is, the more it is to -1. So if you notice that this itself, this light, all of them are 1, 1, 1 up to heating load, and so heating load with itself is 1. Cooling load with cooling load is 1, and cooling load is also positively correlated to heating load, basically. And you can then, so anything that is close to purple, it means that they are not correlated, or they are they are likely correlated, as you can see in this particular heat map. So if they are dark, it means that there's chance that they are highly correlated, and if they are light, which is very light, it means that they are also highly correlated. So all of these lighter colors, it shows you that there's correlation somewhere. So ignore this one that's in the middle. Mostly they are against each other, so they are mostly 1, 1, 1, like that. Let's see. So this one, overall height to relative compactness is positive correlated per se. And if you look at roof area against heat load and cooling load, you can see that they are negatively correlated in some way or the other. So it is, by the time you are now doing this observation, you can then say, okay, if you want to do what they call feature engineering, basically what feature engineering is you look at the features or the columns in your data frame, and you will now start selecting the one you want to use and the one you don't want to use. So like what we did here when we removed this unnamed this unnamed 11, unnamed 10, unnamed 11. When we remove it, it's called feature engineering, literally. So you are trying to so let me put it this way, feature engineering. So basically what you are trying to do is you are trying to get features that are useful to you. So, and you are trying to remove the useless ones, those ones that you don't think they matter to you. Do you understand? So basically, if you are now doing your prediction or you are trying to do predictive analysis, you would say in your data frame, they might give you a question to do some prediction. You already know what you want to predict but you want to say, okay, what is this thing dependent on? So maybe somebody wants to say, they want to know if, for instance, if you have a good wall and rainfall, you are how will I say, or if the thickness of a wall can save you from heavy rainfall. So you can see in the house itself, you have your roof, you have the foundation, you have your decking, but they are now asking you that does the thickness of your wall prevent you from rainfall? So they are talking about size of the wall compared to rainfall, or they are saying the constituent, maybe the ratio of concrete in your wall. Does it prevent you from that you'll be safe from heavy rainfall? So basically, they are already giving you an insight on the features you need to be looking at your data frame. So by the time you're able to, let's say, assuming that they are saying that relative compactness, does it increase heating or so? They are now saying that you should use one to predict the other, basically. Then you can then come and say, new DF, then you just get all the role that you want to make prediction for, which is what we have relative compactness. And what? Heating load. I don't know if the heating load is in capital or small. Okay, heating underscore load. Okay, relative compactness is in capital letter. So by the time you've done this, you've already gotten your the features you actually want to make predictions on, or the dependent or the independent variable. Then you can then now say they are somewhat correlated, but if I were to pick, I'm going to pick something like this. Correlation, I'm going to pick this heating load against or cooling load against, or heating load against overall height. Basically, I can say heating. If I were to pick, I'm going to pick this. If they didn't ask me anything, I can see that they are highly correlated here. And if you do the heat map, you see that they are highly correlated. Well, you can see this 0.8 is highly correlated. So you can actually use this to do your prediction in such a way that you can see the overall height is the X, which is the predictor, and the heating load is your target or your dependent variable. And you can then start your predictive analysis. So basically, for predictive analysis, like I said, linear regression, you are going to import a particular library called scikit-learn, sklearn. Let me see, yeah, sklearn. Or you can say from, and scikit-learn has a lot of libraries. I think from scikit-learn models? I forgot, yeah, model selection, import linear regression, and there are a lot of regression you can actually. Is it model select? No, I forgot it. Bashman, remind me. Oh yeah, so from scikit-learn.linear model, I think it's .linear model, then import linear regression. Yeah. Then you can also do scikit-learn.z. There's also a particular I think it's model selection. There's model selection. There's from scikit-learn.model selection. There's also a library called scikit-learn model selection. Import train test train. I think it's train test split, if I remember correctly. There's also a particular for standardization. There's also scikit-learn dot forgetting that this thing again. Okay, I think it's pre-processing. You can import min max or standard scalar. So you can either import min max or standard scalar. Basically, this is what you are going to be using. Also, you are also going to be using things like I said, the R square score. You are going to be using things like the mean absolute error. You're also going to be using things like it's been a while. I really need to brush on this stuff. Okay, there's mean absolute error. There is mean square error. There's also your R2 score, your R square score. Basically, then so your R square is, if it is closer to 1, your mean absolute error, and your mean square error if they are closer to 0, because you are dealing with error. The less they are to 0, the better. For R square, your R square score, the more it is to 1, the better your model is. I might decide to, I don't have the right data set to actually do this, but I am going to do a tutorials on predictive analysis. I think I've worked on a particular data set before. I cannot remember where it is, but I was trying to find it, but I couldn't before this session. So the highlight of this is, before you do your prediction, make sure that null values are not there. Make sure that your columns are rightly the way it's supposed to be. Make sure that there's also replacing values. They call it, there's a function or a method called fill NA. That is fill NA. That is fill null values with something. And so you can either fill it with nothing, with 0. You can either remove null values, you can fill it with 0, you can fill it with the mean value of that particular column, you can fill it with median, if depending on whether if you drew a normal distribution of that particular column, depending on whether it is normally distributed or if it is skewed, whether towards the right or left, then you can either use the median of that particular column or the mode, or you can remove that column if it has around 70 to 80% null values. If a column has 80 or 70 to 80% null values, it means that you might not be able to use that particular column for anything. So what you just do is to remove it. So I think if I'm chanced, I would do a particular tutorials on predictive analysis. And well, I hope that it will be an entry point to data science for some people here. Any questions before we leave?
Thank you, sir. Any question before we leave?
Today is our last day. I will not be meeting a lot of people. Any questions before we leave? Questions, comments? Everybody's quiet.
Sir, please do more tutorial on Python on your YouTube page, please.
You can
Python.
make a request, and then I will do something.
Okay.
If you have something you want to solve, make a request. I'll do a video for it.
Okay. Thanks so much, sir.
If you have something you want to solve, make a request,
sir.
that you. Sorry, I can hear you, Murtala.
I want to suggest that everybody here should share the link of code and analytics, what do you call it, in action. That's your channel. Everyone should share the link on their status, across the social media. This will be a way of extending your kindness to us and support, and so that we share the